last section we are going to cover before Christmas. It is a very short section, so we should get through this today and leave you with plenty of time to get homework done. That's my intention. We are talking about the derivatives of logs within this. So, first thing I want to do is actually work out the derivative of log. Everything's more fun if we prove it first, right?
Yes.
Good. So, if I rewrote this and said like log base A of x equals, let's say, y, some number y. Hold on one second. So, we could rewrite this as a to the y power equals x. So if I asked you the derivative, I've taught you that, if it's e to the x, the derivative is just e to the x. If it was any other base, such as an a, then it's still the a to the power, but you have to add in the natural log of the base. So it's a to the y natural log of a. Since I did the derivative of a y, what do I need to put with that? dy dx equals the derivative of x is 1. Okay, so if I'm trying to solve for my dy dx, I could divide that stuff over. Okay. But if I didn't want a y in this, what's a to the y equal to? A to the y is equal to x. So I could sub that back to n, and this is 1 over x natural log of a. So the derivative of a log is 1 over the argument times the natural log of the base. Now, for us, what type of log do we prefer to work with? The natural log, because we prefer to work with a base e, since the derivative is nicer. Same thing is going to be true here. If you have the derivative of a natural log, it is just 1 over the argument. The reason being, a natural log is like a log base e. So if you followed that formula that we just derived, it would be 1 over the argument times the natural log of your base. But what's the natural log of e? 1. So that's 1 over x times 1, which is the 1 over x. So this is the derivative that we are going to prefer. We want to work with natural logs so that our derivative is just 1 over the argument.
Okay, let's go. Go big. That's what it's called.
So far, so good? Secret Santas this week? So let's look at this one. So the derivative of a natural log would be 1 over the argument. But since my argument isn't just an x, you have to do the chain rule here. So times, what's the derivative of the inside? 3x squared. So this is 3x squared over x cubed plus 1. I told you it's an x section. That's really all there is to it. Last one was message section. We're making up for it now. That's something I believe you follow with something else. Okay. So, if I wanted to do this derivative, the derivative of the natural log of sine x, what would we do? 1 over sine x times, chain rule here, derivative of sine is cosine. You get cosine over sine. What is that? Cotangent, good. Okay. Keep doing it. This could be written as the natural log of x to what power? 1/2. Square root is a 1/2 power. Okay, so then the derivative, we have to start on the outside. Derivative of the outside, so the 1/2 comes down, inside stays the same. Subtract 1 from the power. Times derivative of the inside. Derivative of natural log will be 1 over x. And we could simplify this a bit. Everything here, the natural log had a negative exponent, so everything's going to be on the bottom. Just be 2x times the natural log of x to the 1/2, or the square root of the natural log of x. Want to try one that's not a natural log? Okay. So, derivative of a log. We have to use that first rule we derived, which is just 1 over the argument. But since this is not a natural log, you also have to multiply by the natural log of the base, so natural log of 10. Am I done? No, since the argument wasn't just plain x, you have to do the chain rule, so times derivative of the inside. Derivative of 2 is 0, plus derivative of sine x is cosine x. So you get cosine x over the 2 plus sine x times the natural log of 10. So far, so good? Okay. So, derivative of the log is 1 over the argument. I'm going to write this as a 1/2 power. Just help us out. Times, what do we, quotient rule. The derivative of the inside, we're going to do quotient rule. So low is x minus 2 to the 1/2. D high, what's the derivative of the top? 1. Minus high, so the x plus 1. D low, derivative of the bottom, so the 1/2 will come down. Inside stays the same, subtract 1 from the power. All over low squared. we really have a significant amount of reducing to do here. This is not okay for our finding. So, first of all, we can't have a fraction within a fraction. How would I rewrite this mess? Yeah, just flip the bottom and multiply. So it's just 1 times the reciprocal of that, which really just flips this piece. In this term, can I leave that 1/2? So the best way to fix this is just multiply top and bottom by 2. So I would get a 2 times my x minus 2 to the 1/2 minus this 1/2 and 2 would drop. On the bottom, if you square that, you multiply those exponents, and that just turns into a 1. Let's keep going. Let's simplify this one all the way. So if we distribute this, take this to both terms on the top. When you do that, you add exponents. So x minus 2 to the 1/2 times x minus 2 to the 1/2 will be x minus 2 to the first. These negative 1/2 and 1/2 drop out. We distribute. Ending up with x minus 5 over 2 times x minus 2 times x plus 1. Question 6. That one was a little bit ugly, just with the algebra to simplify it. That's really the end of this section. Now, a few things. You're going to have a few homework problems. It's a fairly short one. Like 7 problems. Tomorrow, I would like to do a quiz over sections 3.5 and 3.6. 3.5, I am not going to put any of the trig functions, or there might be trig functions. There won't be inverse trig functions on the quiz, but there will be the other things. Should we maybe do a couple sample problems from that? It's going to be a short, well, 5-question quiz, 3 questions from 3.5 and 2 questions over the derivatives of logs. So 2 of questions like what you're doing for homework tonight. Let's do a couple team problems. I'm going to put them up here, and I would like for you guys to find them. Let's do try these 2 to get us started. What do you have to do for this first one? product rule. So derivative of the first, derivative of x is 1, times the second, plus the first, derivative of the second. Okay, derivative of cosine is negative sine, angle stays the same, times the derivative of 3y would be 3 dy dx. Okay, product rule on the second side. Derivative of y would be dy dx times the second plus the first, which is y, derivative of the second. Derivative of sine is cosine, angle stays the same, times derivative of the angle would be a 3. I need my dy dx's on one side, everything without it on the other. So I'm going to leave this cosine y here. I'm going to subtract over this term, which I'm going to write as 3y cosine 3x. I'm going to leave this. Can I pull out my dy dx at the same time? Kind of combining steps. So if I lose you, let me know. Oh, yep, thank you. Just dropped my 3 right there. Okay. I'm going to bring this term over so it'll become a positive 3x sine 3y. So we divide, so we get cosine 3y minus 3y cosine 3x over sine 3x plus 3x sine 3y. So you'll have something like that on your quiz, making sure you can do, and that has a lot of pieces combined in one. You know, making sure you still remember the derivatives of your trig functions, your product rule, your chain rule, and the dy dx's, all in one problem. Is that one okay? Second one, if I want y double prime, so first derivative, you would have bring down your 2 times 9 would make that 18x plus derivative of y squared would be 2y dy dx. Derivative of 9 would be 0. Subtract over the 18x. Divide by 2y. We can review. So your dy dx is negative 9x over y. Yes.
Would we not have been able to solve it?
You could have, and then done your derivative twice from there. Now I need my second derivative. So we're going to do quotient rule. So low d high is negative 9 minus high d low, derivative of y would be dy dx over low squared. We get negative 9y plus 9x, and what am I going to plug in for dy dx? Negative 9x over y. Okay, different ways you could simplify this, but we ultimately can't leave a fraction within a fraction, so I'm going to multiply by y on top and bottom. So our second derivative is negative 9y squared minus 81x squared, the y's would cancel on that one, over y